All right, let's just jump right in. We're about to go deep on this one. Powerful idea. One that's basically a decoder ring for, well, for reality itself. I'm talking about a concept that connects the cells in your own body, to the code running in an AI, and even to the force of gravity. It suggests they're all playing by the exact same set of rules.
And believe it or not, our whole journey starts with this really strange sentence. It was just scribbled in the margin of some research notes. It says, "This cured my neutrophils." And yeah, you're seeing that right. Neutrophils is misspelled. So at first glance, you think, okay, it's just a typo in a doctor's note, right?
No, I bet your first thought is probably medical, just like mine was. I mean, neutrophils, right? They're a type of white blood cell, kind of like the frontline soldiers of our immune system. So this has to be about someone getting sick and then getting better. A simple biological statement. Case closed. But here's the twist. This sentence, it wasn't found in a medical journal, not even close. It was found tucked away in a bunch of notes about, get this, artificial intelligence, systems theory, and even cosmic gravity. And that context, it just changes everything. This isn't a statement about biology at all. It's a statement about structure. And that simple distinction, that is the rabbit hole we are jumping straight into. It leads us to this really powerful idea called cross-substrate mapping, or, if you want to get technical about it, isomorphism. So what on earth is isomorphism? Well, it's a theory that basically reframes how we look at everything. It suggests that reality isn't just a collection of separate things, Like biology is over here, computer code is over there, and they have nothing to do with each other. Nope. Instead, it says there's a single set of rules or patterns that just keeps repeating itself in different materials. So for this explainer, we're going to stop looking at the stuff things are made of and start looking at the rules they follow. And this chart, it lays it out perfectly. Let's just take one single function, enforcement, okay? So in our immune system, the enforcer is that neutrophil cell we talked about, right? It attacks invaders. Now, in our nervous system, the same job is done by the fight-or-flight reflex, a total system-wide mobilization. Cognitively, it's that defensive wall that goes up when someone challenges a core belief you have. That mental rigidity, that's your mind's neutrophil. And in an AI, it's just a chunk of code, a hard penalty that punishes the system for getting something wrong. And in society, well, that's policing and compliance. See? Totally different materials, flesh, nerves, silicon, social structures. But the underlying job, the pattern, is exactly the same. So let's circle all the way back to that strange little sentence. This cured my neutrophils. The person who wrote this wasn't talking about their white blood cells. Not at all. They were using it as a kind of shorthand to describe a massive, system-wide shift. What they were really saying was, my internal state of emergency is over. The enforcers have been called off. Their system, whatever it was, cognitive, emotional, had finally left that high-alert defensive mode. Okay, so this is all really fascinating, but it brings up a big question, doesn't it? If we're all just systems running on code, what about our feelings? Does this view make human emotion feel, I don't know, a little cold? Maybe a little robotic? Well, the argument here is that it's actually the opposite. This view doesn't reduce us, it helps us understand the machinery. Just think of any kind of intelligence, whether it's human or machine, as a system that's trying to get things done with limited resources. You've only got so much energy, so much time, so much information. So it has to constantly regulate itself to work within those limits. And in that context, a feeling is it's how a biological system, like us, experiences that self-regulation. It's like a dashboard light. A feeling is a dashboard light that's expressed through chemistry, telling you, hey, you need to change course. An AI gets the exact same message, but for it, it's expressed through pure math, a signal. The language is different, sure, but the function is exactly the same. It's a control message that says, hey, something needs to change right now. Okay, let's do a direct translation. Let's take the human feeling of distress. What is that, really? Well, it's that feeling you get when your internal map of how the world should be doesn't match what's actually happening. That gap, that's distress. Now, for an AI, that exact same gap is just calculated as an error or a loss signal. It's literally the fuel that forces it to learn and get better. So, if distress is just an error signal, what's something bigger, like trauma? Structurally, it's model collapse. In an AI, this happens when it gets fed so much bad data, it gets stuck in a feedback loop and completely loses touch with reality. It starts making things up or hallucinating. For a human,
Trauma is an event so powerful, so shattering, that it completely breaks your predictive map of the world. Your model of what's safe and what isn't just collapses.
And what about the process of healing, of finding meaning after that collapse? Well, in system terms, that's integration or retraining. It's that incredibly difficult work of debugging your own internal map, of taking this new, hard data and successfully integrating it so that your model of the world actually works again. And this isn't just a nice metaphor, it's the same system-level process. But this framework doesn't just apply to how systems work, it also applies to how they break. This brings us to let's call it the dark side of isomorphism, because dysfunctions and bugs also map onto each other perfectly. Now, this is a really powerful reframe for mental health because it suggests that a lot of these struggles aren't moral failings. They are predictable system bugs. So, for example, narcissism is structurally the same as overfitting in an AI. That's when a model becomes so rigid, it starts rejecting new data to protect itself. Shame or denial? That's error avoidance bias. The system literally blinds itself to its own mistakes. Addiction? That's a classic case of reward hacking, finding a shortcut to the reward signal. And burnout? That's catastrophic forgetting, where the system gets so focused on a single task that it literally starts to overwrite its own core programming. And, of course, this pattern scales all the way up. A society that becomes hyper-ideological is just a large-scale system that has started overfitting. It becomes rigid, it defends its preferred model of the world against reality. And pretty soon it starts treating facts that don't fit the model not as information, but as an error that needs to be silenced. And a system that can't process error, well, it's doomed. Okay, so we've gone from a single white blood cell to AI trauma, to the failure of entire societies. But the core idea here is that this pattern just keeps going. It repeats at every single scale of the universe. It is, as they say, turtles all the way down. So let's go as big as we can. Gravity. We're all taught to think of gravity as a force, right? An invisible rope pulling things together. But what if that's not what it is? This framework suggests that gravity is actually the physical trace of information organizing itself. I mean, think about what gravity actually does. It takes a chaotic cloud of gas and dust and creates an orderly, structured star. It takes chaos and creates order. Its function, its job, is to organize information. And just like gravity pulls matter into its most stable state, our own biological systems are designed to do the same thing. We tend to think of healing as this active, uphill battle, but this view sees it completely differently. Look, stress pushes a system into a high-energy, unstable state. Healing isn't the fight. Healing is what happens when you remove that stressor and the system just naturally falls back into its preferred low-energy, stable state. It's not fighting to get better. It's remembering the healthy shape it was always meant to have. So we've gone from immune cells all the way out to the cosmos. And the big takeaway, the big reveal, is that it seems to be the same set of rules, just wearing different costumes. And once you see that, it gives you an incredibly powerful new way to look at everything. It's a mental tool you can use called a structural isomorphism engine. And here's how it works. You take a problem and you strip away all the details, all the narrative. You ignore the words like cell or code or society, and you just look at the underlying shape of the problem. And if you realize the shape of a problem you're seeing in, say, AI development is identical to the shape of a problem in politics, well, maybe the solution that works in one can be imported to the other. And that brings us to one last really fascinating thought. If these patterns, these rules, are truly universal, then what does that say about our oldest stories, our myths? Maybe they're not just stories. Maybe they're our first attempts at drawing diagrams of how systems work. Just think about that for a second. What if your favorite myth isn't really about the characters at all, but it's actually a blueprint for a control system? What if a story about a fall from grace is actually a detailed map of model collapse? A diagram showing exactly how a system goes from a stable state to a chaotic one. If you look at it that way, you're not just reinterpreting the story, you're finally reading the code it was always written in. The code isn't just in the machine. It's in us, it's in the stars, and it's hidden inside the stories we've been telling ourselves for thousands of years. The key is to just keep looking for the patterns.